Hi students and friends, welcome to the channel Learn and Teach by Ayaz. I will continue my video lesson for IGCSE 0620 past papers, and this time I have selected the paper October-November 2022 and the paper is 41. So these are the instructions for this paper. Answer all questions. Use a black or dark blue pen. You may use an HB pencil for any diagrams or graphs. Write your name, center number, and candidate number in the boxes at the top of the page. Write your answer to each question in the space provided. Do not use an erasable pen or correction fluid. Do not write on any barcodes. You may use a calculator. You should show all your working and use appropriate units. Information for this paper. The total mark for this paper is 80. The number of marks for each question or part question is shown in brackets. The periodic table is printed in the question paper. So here's a question number 1. The names of the elements of period 2 of the periodic table are shown. Answer the following questions about these elements. Each element may be used once, more than once, or not at all. Identify the element which is a product of photosynthesis. You know, during photosynthesis, two products are produced. One is glucose and other is oxygen. So if you look at the options, you have oxygen here. So you write oxygen. B has an oxide found in clean, dry air. Carbon is the element which has oxide found in dry air. So we'll write carbon here. C forms a basic oxide with the formula X2O. First of all, we'll pick the metals from the list because metals form basic oxides. We have lithium, beryllium, and boron. Lithium belongs to group 1. So the formula between lithium and oxygen will be, recall the valency of lithium, which is +1. The valency of oxygen is -2 because oxygen is in group 6. Ignore their charges. The final formula will become Li2O. So the answer will be lithium. D is a main component of fertilizers used to improve crop growth. Nitrogen is a main component of fertilizer used to improve crop growth. E has the highest rate of diffusion at room temperature. Look at the gases in the choices. We have neon, fluorine, oxygen, nitrogen. I'm writing their formulas. Nitrogen exists in diatomic state, N2, oxygen, O2, fluorine, F2, neon, and E. So look at their nucleon number so that we can calculate the MR or AR. For neon, it's 20. Neon, it's 20. Nitrogen, N2. 2 multiplied by 14, it's 28. Oxygen, O2. 2 multiplied by 16, 32, fluorine F2, 2 multiplied by 19 should be 38. So neon will be the right answer for this. So we'll write neon. F produces a red flame in a flame test. Lithium is a metal which produces red flame in the flame test. G has only 5 electrons in each of its atoms. We have to look at the proton number of these elements from the periodic table. For lithium, the proton number is 3, beryllium it's 4, boron is 5, carbon is 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. So it must be boron because this is the one which contains 5 electrons in each of its atom. H has an oxide responsible for acid rain. We have 2 non-metals in the list which form acidic oxides, that is nitrogen and carbon. Nitrogen forms NO2, carbon forms CO2. Both are responsible for acid rain, but the main culprit is nitrogen dioxide. So we'll write nitrogen here. Number 2, potassium is a group 1 element. A, name and describe the bonding in potassium. Potassium is a metal. So straight away the name of the bonding will be metallic. Now in the description, we'll talk about the lattice of metal ions. Here we have potassium, so you'll write lattice of potassium ions. Second point will be sea of electrons. The last point will be the attraction between positive ion and electrons. Next question. B. Potassium combines with sulfur to form an ionic compound, potassium sulfide K2S. Give 2 physical properties of ionic compounds. You can write any 2 physical properties from these. Like you can write high melting point or boiling point. You can write dissolve in water or soluble in water. You can even write exist in solid state. Conduct electricity. In molten state or in aqueous. Aqueous means when dissolved in water. Number 2, complete the dot and cross diagram to show the electron arrangement and charges of ions in potassium sulfide. So potassium sulfide, the formula will be K2S. Potassium belongs to group 1, so it will lose 1 electron to form positive ion. So we'll show all the electrons present in potassium atom. Proton number of potassium is 19. After losing one electron, it will be left with 18. So two shells are shown. 2 plus 8 will be 10. 8 electrons are left. So I will show the rest of the 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Similarly, this one also contains 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Now sulfur. Sulfur belongs to group 6. It will gain 2 electrons to acquire minus charge, minus 2 charge. So I'm going to show 2 electrons coming from each potassium atoms in total. One from this one and one from the other one. Now let's show the valence electron for sulfur. 1, 2, 3, 4, 5, 6. This will be your final answer. See, when potassium is added to water, it reacts vigorously and a colorless flame is seen. The equation for the reaction is shown. 2K solid plus 2H2O liquid gives 2KOH aqueous plus H2 gas. Number 1, state the color of the flame seen. The color of the flame will be of potassium, which will be lilac. Number 2, the solution formed is potassium hydroxide, a strong alkali. State the formula of the ion responsible for alkalinity in the solution. It is OH negative ion. Number 3, state the color of litmus in a strong alkali. It will turn to blue. Number 4, calculate the volume in centimeter cube of hydrogen gas formed when 2.34 gram of potassium is added to excess water at room temperature and pressure. I'm writing the reaction equation here for your convenience. We have 2K plus H2O gives 2KOH plus H2. So you use the following steps for this one. Calculate the number of moles of potassium added. So we'll convert this gram into moles of potassium. We have 2.34 grams of potassium. You will multiply 2.34 by the AR of potassium, which is 39. .34 divided by 39.06 moles. Determine the number of moles of hydrogen gas formed. So let's see the relationship between these two. We have 2K and 1 mole of H2. So 2 moles gives 1 mole of hydrogen gas. Therefore, 0.06 gives X mole. So we'll do the cross. We'll get X is equal to 1 multiplied by 0.06 divided by 2. 0.06 divided by 2. 0.03 moles of hydrogen gas. Calculate the volume of hydrogen gas formed. You have the moles of hydrogen gas. Simply multiply these moles by the volume at RTP. You have to take the value in centimeter cube because the answer is in centimeter cube. So you'll multiply 24,000 by 0.03. 0.03 multiplied by 24,000, 720 centimeter cube. This will be the final answer. D. Aqueous potassium hydroxide reacts with a dilute acid to produce aqueous potassium chloride, KCl aqueous, which is a salt. Number 1, name the dilute acid used. You see you have chloride here. So the chloride comes from acid HCl or hydrochloric acid. So we'll write hydrochloric chloric acid. Number 2, state the type of reaction taking place. Whenever acid reacts with alkali, we have neutralization reaction. Potassium hydroxide is alkali, so you write neutralization. Number 3, name the experimental technique used when salts are made by reacting a dilute acid with an aqueous alkali. Just titration. E. When aqueous silver nitrate AgNO3 aqueous is added to aqueous potassium chloride, a precipitate is formed. Number 1, state the color of the precipitate form. When we react potassium chloride KCl plus aqueous silver nitrate AgNO3, we will get these products. We will get KNO3 plus AgCl. AgCl is insoluble white precipitate, so we'll write white here. Number 2, name the precipitate form. I've just mentioned silver, it's of silver chloride. Number 3, write the ionic equation for the reaction, include state symbols. So these all will be aqueous. The reactants both are in aqueous state. Potassium chloride and silver nitrate aqueous. On the product side, potassium nitrate, it is also soluble, so it will be in aqueous state. And silver chloride, it is white precipitate, so we'll write S for this silver chloride. Cancel out the common ions on both sides. K ions is common, nitrate is also common, so we are left with Cl negative aqueous plus Ag plus aqueous gives AgCl solid. Number 3, ammonia is made in an industrial process starting with nitrogen. The equation for the reaction is shown. This is the reaction equation. N2 plus CH2 gives 2NH3. A, name the industrial process used to make ammonia. It's Haber process, so we'll write Haber. B, state the raw material from which nitrogen is obtained. Nitrogen is obtained from air, so you write air. C, state what is meant by the symbol. This is a sign of reversible. D, state the temperature and pressure used in this industrial process. The temperature used is 450 degrees centigrade and the pressure will be of 200 atm. E, name the catalyst used in this industrial process. The catalyst is iron. You're also allowed to write the symbol for iron, Fe. If the forward reaction is exothermic, state the effect, if any, on the position of the equilibrium when the following changes are made. Explain your answer. For your convenience, I am writing the reaction equation here. N2 gas plus 3H2 gas gives 2NH3 gas. Forward is exothermic, so you write delta H is equal to minus. So we'll write the effect of on the position of the equilibrium when temperature is reduced. Equilibrium will shift towards the right hand side or product side. Equilibrium will shift towards product or right hand side. The reason, forward is exothermic, or you can even write or backward is endothermic. Pressure is reduced. Whenever you decrease the pressure, the equilibrium will shift towards the side with the highest number of moles or volume of gases. So let's count the volume of gases on both sides of the equation. On the reactant side, it will be 1 plus 3, which means 4. The product side, it's 2. So equilibrium will shift towards the reactant side. Equilibrium will shift towards reactant side or left hand side. Reason: higher number of moles or volume of gases on left hand side or reactant side. You can even write lower number of moles or volume of gases on right hand side or the product side. Explain in terms of particles what happens to the rate of reaction when temperature is reduced. Now you have to explain in terms of the particles. So you'll write rate decreases. Because particles have less energy. There will be less collisions between particles. Per second. Then you can write less particles have energy equal to or above the activation energy. Less number of particles have energy equal to or above activation energy. Number H. Give the formula of the compound formed when sulfuric acid reacts with ammonia. Whenever you react acid with ammonia, especially mineral acids, we will get ammonium salts. So the ammonium salt must have ammonium ion here, and the salt will be of the negative ion present in the mineral acid. Here the negative ion is sulfate. So we'll get ammonium sulfate. The formula will be, let's predict the formula. Ammonium will carry +1 charge, sulfate will carry -2 charge. Ignore their charges. These subscripts will be exchanged now. You will get NH4 whole twice SO4. This is ammonium sulfate. Number 4, a student prepares calcium nitrate CaNO3 whole twice by adding calcium carbonate to dilute nitric acid. Write the chemical equation for this reaction. So calcium carbonate, the formula of calcium carbonate will be CaCO3 and nitric acid will be HNO3. We'll get 3 products. We'll get metal salt, that will be calcium nitrate CaNO3 whole twice plus water plus carbon dioxide gas. B. Describe 2 observations during this reaction. This is a reaction between metal carbonate and acid. So effervescence of fizzing will be the common one. Effervescence or fizzing. Number 2, solid disappears or dissolves. Solid dissolves. C. The student continues to add calcium carbonate until it is in excess. The student then removes the excess calcium carbonate by filtration and collects the aqueous calcium nitrate. State the general term given to a solution collected from filtration. We call it filtrate. D. The student gently heats the aqueous calcium nitrate until the solution is saturated. 1. Suggest what is meant by the term saturated solution. Solution that cannot hold any more solute particles. Solution that cannot hold or dissolve any more solute. Number 2, describe how crystals are produced from a hot saturated solution. Simply cool the solution. E. Calcium nitrate crystals are hydrated and have the formula CaNO3 whole twice dot XH2O, where X is a whole number of molecules of water. The student heats the crystals to remove the molecules of water. This is the equation for this reaction. State the term used to describe the calcium nitrate after the molecules of water have been removed. We call it anhydrous. Number 2, the student heats a sample of CaNO3 whole twice dot H2O and forms 2.46 gram of CaNO3 whole twice and 0.06 moles of H2O. Determine the value of X. Use the following steps. Calculate the MR of CaNO3. So we want to calculate the MR of CaNO3 whole twice. The nuclear number of Ca is 40. For nitrogen, it is 14. So we have 2 atoms of nitrogen, so we'll multiply it by 2 by 14. What about oxygen? Oxygen, 2 multiplied by 3 is 6. The nuclear number of oxygen is 16. So if you'll add up these, you will get 164. Determine the number of moles of CaNO3 formed. Now we want to calculate the number of moles of CaNO3. So you'll simply divide the mass by the MR of CaNO3 whole twice. 2.46 divided by 164. 2.46 divided by 164. 0.015. 0.015 moles of CaNO3 whole twice. Determine the value of X in CaNO3 whole twice dot X H2O. So we have the moles of CaNO3, which is 0.015. CaNO3 whole twice, here water, 0.015 moles contain 0.06 moles of water. 0.06 moles of water. Therefore, 1 mole contains X mole of water. We'll do the cross. You get X is equal to 0.06 multiplied by 1 divided by 0.015. So 0.06 divided by 0.015. The answer will be 4. So we'll have 4 as the value of X. F. Nitrates decompose on heating. Write the chemical equation for the reaction when solid sodium nitrate is heated. Whenever you heat sodium nitrate, you will get 2 products. You will get nitrite and oxygen gas. So you'll have NaNO3. The formula of nitrite will be NaNO2. NaNO2 plus O2. Let's balance the equation. Oxygen will be 4 on the right hand side. So we can, if we'll write 2 before 2NaNO3, then we can balance on the right hand side. On the right hand side, we have to make it 6 oxygen. So in order to make oxygen 6, we have to multiply the sodium nitrite by 2. So this will be the final equation. 2NaNO3 gives 2NaNO2 plus H plus O2. Number 5, ethene is an alkene which reacts with bromine as shown in the equation. C2H4 plus Br2 gives C2H4 Br2. A, write the general formula of alkenes. So you'll have CnH2n. This will be the general formula of alkenes. B, describe the color change seen when ethene is bubbled through aqueous bromine. The color will be changed from orange to colorless. C, in this reaction, only one product is formed from 2 reactants. Name this type of organic reaction. We call it addition reaction. D, part of the energy profile diagram of this reaction is shown. Number 1, the reaction is exothermic. Complete the energy profile diagram for this reaction. Include the position of the products, an arrow to show the activation energy labeled as A, an arrow to show the energy change for the reaction. This reaction is exothermic, so the product will be at the low energy state. We have an energy hump like this. This will be the product. So the product is C2H6Br2. Now I have to label the activation energy. The activation energy will be this. Label it with A. An arrow to show the energy change for this reaction. This will be the arrow for energy change, which is delta H. Number 2, the chemical equation for the reaction can be represented as shown. This is the reaction. Some bond energies are given. You see the bond energy for CH, C double bond C, Br, Br, C bond C, CBr is given. Use the bond energies in the table to calculate the energy change in this reaction. Use the following steps. Calculate the energy needed to break bonds. So we have one C double bond C. So I will write 610 here. Plus there are 4 CH bonds, 1, 2, 3, 4. So 410 will be multiplied by 4. There is one Br bond. So we have 190 here. Now let's add these values. 4 multiplied by 410 gives 1640 plus 610 plus 190, 2440. Calculate the energy released in making bonds. So these are the bonds made. We have one CC bond. So you have 350 plus 1, 2, 3, 4. 4 CH bonds. So again, you will multiply 4 by 410 and 2 CBr bonds. 1, 2. For CBr bond, we have 290. We will multiply it by 2. So 2 multiplied by 290 will be 580. 410 multiplied by 4 will be 1640. Then add 350. 1640 plus 580 plus 350. 2000 570. Determine the energy change in this reaction. You know, energy needed to break the bonds minus energy released in making bonds. So 2440 minus 2570. 2440 minus 2570. You will get minus 130. This will be your final answer. 6. Ester Y has the structure shown. This is the ester. A. Name ester Y. This will be the alkyl group and this will be alkanoid group. Both contain one carbon, so it will be methyl methanoate. Methyl methanoate. Number 2, deduce the empirical formula of ester Y. I will write the molecular formula. Count the carbon atom. There are 2 carbon atoms, hydrogen, 4 hydrogen atoms, oxygen, 2. So it will be CH2O. This will be empirical formula of this. B. Complete the dot and cross diagram to show the arrangement of electrons in a molecule of ester Y. So we have dots for carbon. For left hand side, we have 1, 2, 3, 4. For the right hand side, we have 1, 2, 3, 4. Now let's show the valence electrons for each hydrogen atom. 1, 1, 1, 1. For oxygen atoms, we have to show 6 valence electrons. 1, 2, 3, 4, 5, 6. Now the oxygen atom, top of the carbon, 1, 2, 3, 4, 5, 6. This will be your final dot and cross diagram. C. Ester Y can be made by reacting 2 organic compounds together. Name the compounds and draw their structures. Show all of the atoms and all of the bonds. So you'll have methyl coming from methanol. Methanol gives methyl. And the structure of methanol will be, met means 1 carbon. And it's an alcohol, so you will place OH and hydrogen atoms. Alternatively, you can draw in this way also, showing each bond. The second will be the alkanoid group, which is methanoate, coming from methanoic acid. It's giving methanoate. So methanoate, again 1 carbon. This will be the final structure for methanoic acid. D1, describe what is meant by the term structural isomer. Same molecular formula, different structural formula. Same molecular formula, different structural formula. To name a carboxylic acid which is structural isomer of ester Y, you can write ethanoic acid. Thanks for watching. Press like and share my videos. Give comments. For more videos, subscribe to my channel and press the bell icon.